Hello everyone, it's the third day and we had great topics and I see many connections across topics being presented here at JCon, trying to solve many similar problems, trying to view many similar things from different angles. And I hope that I will put my coin into this picture. So we are going to discuss a very naive topic, I would say. Because from my perspective, of course, yes, you need different performance tests, and in particular in Kubernetes, and that's kind of obvious, right? But we will see what exactly do I mean here. My name is Dmitry Chuyko. I work at a company named Bellsoft, and I'm OpenJDK committer. And we have many great OpenJDK folks in our company. And we release our own binary distribution of OpenJDK called JDK, which is recommended Spring Boot JDK distribution and a default distribution in Spring Boot build packs. So if you ever created a container using Spring Boot, you probably already used the JDK. And based on that interesting problems that arise in our area, we realized that yes, containers are super important just many years ago. And we started to work on that. And we realized that we also need to provide another part of the stack, so we created a Linux distribution called Alpakita Linux, which is a lightweight and secure Linux, fully compatible with Java and native images, so it's super easy. So let's start with a small story. It continues through years, so maybe I'll put some additions here. So one of our friends is responsible for running Java in Kubernetes in a very large American enterprise. And he's kind of opened a new world to us. The world, what happens inside, right? And the story is like that company successfully migrated to the cloud. And they upgraded many of their systems to newest, latest and greatest microservice architecture, modern frameworks, all running in containers in Kubernetes. Fine. 2 years of work, many people, some people, of course, left the company right after the project ended up. And then a few months pass, right? And what happens? So everybody's happy, right? Developers are happy, they made it. DevOps are happy, they made it to production. Cloud ops are happy, super happy. Again, it's a new thing, well, maybe some interesting issues to fix, but in general it works, right? I'll monitor it. Well, who is not happy is FinOps and business, who gets their bill for that cloud after some time. Especially, it may be a long time, because, well, maybe they started in summer and something happened closer to the end of the year. Yeah, it happened. And they said, well, we are not ready to pay 10 million a month, every month, or sometimes more. Let's do something. Well, how do you think? What's the problem here? What's the missing part? From my perspective, the missing part is making developers aware of what happens in their cloud. How much does it cost? How much resources are wasted, right? Because who controls their applications? Teams who develop it. Not teams who deploy black boxes, those containers. And what happens after that? That company tries to solve this issue in a different way. They say, okay, we will buy service. Some other guys will come and provide a solution for us how to reduce our cloud costs. So how long does it take, how do you think, to adopt such a solution in a big enterprise. They're fast. It took only about a year. So in the result, they had an interesting outcome. First, their data goes somewhere to the other service. And second, to provide a work of this component, you need extra machines in your clusters. Nice. That's a success, right? Savings, cloud savings, services. Do nothing, just take those benefits. Meanwhile, for a long time, Java is very effective in running containers. And even if you're on Java 8, who is in Java 8, by the way? Yes, thank you. Love you guys, because we sell support. Java 8 is container-aware for some years. Just please don't miss that updates. It's available for free in different OpenJDK distributions. It's not a problem. Well, but we know that we still need to tune that Java properly, because many people go to a very straightforward and simple, and to my perspective, wrong road. Just put default options to JVM in your container. Whoever saw this? No, that's the wrong question. Who haven't seen this? Yes. now it's correct. No hands. Yeah, because that's what happens. But how would we organize this work? What should we require from our applications, from our developers, from our different parts of our organizations? Well, we have some business requirements, constraints of how much the organization is willing to spend on its cloud. What level of service should be provided? Like what's the response time? When customers start to be unhappy? And what technicians must watch to back this to make it working? So this splits up to 3 areas, right? We have a service level agreement, which is a high level business perspective or user perspective. We have low level indicators that our developers and services can collect for us. And not all information that can be collected is useful, right? But we can collect useful information. And then there are objectives, right? When we say, okay, those indicators must accommodate, must satisfy some rules. That's ISLOs. So they all must be determined and defined. So you must determine what indicators are critical for you and how do you monitor them and see either it's good or bad. And we can also say how much do we satisfy our requirements, right? Because we may want to have 0 downtime, right? But if we had 100 minutes of downtime last year and 50 minutes this year, probably we are doing the right thing, right? It's not 0 yet, but we are moving towards having 0 downtime. So in that objectives, we of course remember many internal things, but it's important how they work combined, right? If we talk about latency, right, there are different components. For end user, the overall latency is important. When we do monitoring, of course, we split it to different parts, like what happens on client side, what happens in different parts of our probably distributed system that performs backend work on some requests. And when we do that, we fall down to JVM indicators, right? Of course, we collect logs, GC logs. We take JMX metrics. We can be historically stored, analyzed with graphical tools or data analysis tools, right? That's how it works. But what really happens here is that we have two actually different goals. We may want to save some resources, or we may want to perform more work, or at least so our goal is to have both. Well, we can do both. We can fail at both. We can do a very little work with wasting very much resources. How does it happen? Of course, easily. Just leave it as is. If it works, it probably works ineffectively. Unless you rely on some components that at least promise you that you'll get some effective work. We'll see some of them. Well, at least one. So this is from a report of 2020 of Datadog, famous APM. And that's still true. And I think even more different container deployments are underutilized. They're underutilizing their underlying hardware, their cloud resources. Maybe they made an update next year, but yeah, same numbers. And the more you rely on your service SaaS provider, right, like your cloud vendor, the more you probably underutilize, because that's the key point, how the money is made, right? It works. You pay for not managing it, and probably it's less effective than having manual management and squeezing all the capabilities of what you have. So yes, things like elastic scaling, right, auto scaling are expensive. They may be expensive at least. Though even cloud providers themselves publish recommendations how to reduce costs for their users. Well, because it's also convenient and it brings some benefits for them. So in the end, we have that picture, right? We have some containers and their contents, well, doesn't correspond to their size or the resources that they require. And it happens with the same company that provides, automated container management and managed Kubernetes solutions. Well, but here, the goal is accomplished, right? It's a safe delivery. We have all that seeds safe and delivered to us. No problem, it's just a waste of resources. But that wasn't a constraint until some time. So I don't think I have to make a long stop here. So containers are obviously useful, and we use now them not just for production but also for development. We use lightweight virtual machines that run just containers. We run containers from different architectures. By the way, read our blog, we have some interesting insights on that. And yeah, inside that, support for containerization in hotspot virtual VM, hotspot virtual machine. It has a few notable points just to remember, that your defaults may change depending on how much resources do you have, and some values always depend on resources that you have and the information that is provided by the environment, right, by your host environment, and what you can see from the inside of the container, and what you shouldn't do or should do, right? It's a decision of the JVM implementation. So now it's smarter than it used to be. Well, yes, let us tend to put too few resources for JVMs. People say, use a half of CPU, do such nasty things. Who haven't seen that? Again, the same question. Right? It's related to Java 8 and default JVM options. Well, people do that. Though I find it's ineffective, And the purpose of this talk is to show that you can easily check either if it's useful or not. Well, we know that in containers we have some major resources that are CPU and memory, right? And I would say we should hint the JVM how much memory should it use, right? Because nowadays it can't determine it automatically. That would be nice. Though it's tricky. And the only thing is that we must experiment and make it not break and use our resources. Again, there are helpers, but they don't give you a guarantee that things won't break. So you must experiment for all of your services. You must check your native memory tracking information to see how much native memory do you need, and you must experiment with the number of your threads and other parameters to see how much different types of memory do you need. So in the end, we take that containers and run them somewhere. It may be Docker Compose, other systems. And finally, probably we go to Kubernetes, some sort of, which is a helper or a service that aligns your configuration with what actually is running on your cluster. So it takes your declarations about what you will to see and creates running processes on different machines for you to satisfy that declaration. And remember, we put JVMs there. So we get the same resource information, but we are being executed in a slightly different system, right? Not in a sometimes, well, at least not in our development environment, right? At some environment somewhere in the cloud where there's a host operating system that runs some container management engine that finally brings your process, right? It's a process on the host operating system. In the end, your JVM running that container is just a specially designed process. So it has all the same things. So, you know, there are different strategies, right? And, well, yeah, here it's a small stop about limits and defaults in Kubernetes. Kind of obvious, right? If you set some actual, and you get some actual resources for your pod, then your JVM calculates its parameters, right? And you can also provide some hints to this calculation to use proper ratios, etc. We'll see simple examples later. So we finally managed to run some production, right? It somehow works. Everybody's happy until that, you know, that day comes, like Black Friday or whatever, and everything just goes down, right? Everything crashes. We need to scale fast, and sometimes it's just not possible because of the deployment strategy and because of the lack of the knowledge about our services. Well, of course, it's critical to scale what is critical. So we must be able to create more instances of our critical services rapidly. Probably we have to create them in advance or create portions of such instances in advance, right? That's the scaling strategy. And after that, right, we have to downscale because that day is over. We don't need them anymore. Otherwise, the build will be enormous. And for less critical services, we can collocate them on machines, we can squeeze the requirements, or even there may be circumstances when some applications require resources when some others don't. So we can collocate them and exchange that resources. For highly critical services, of course, we should put our constraints equal to our requirements. Otherwise, there will be trouble. And another story is from not so large, but a bank in Europe, and they saw container failures. And when we checked, they say, yeah, we have it. We just put our XMX slightly larger than the memory limit in the container. Well, why? Well, it works, no problem. But just sometimes it crashed. And then it restarted, it worked for some time, right? And then it crashed at a random place again. It happens. With Kubernetes, we can collect additional metrics, kind of bots pretend to be real machines, so we get those metrics. And in any case, we have all that information about processes. Our JVMs are just processes running somewhere. And besides JVMs, there are service parts, right, of the kubelets that help to run our JVMs as processes and manage them, start, stop, etc. So we need to collect that metrics too as indicators, right, for our SLOs, for our monitoring. Well, and when we scale, in modern days, no one probably has a single monolith. There's also always a dependency. It may be as simple as a dependency on the database, right? But even in that case, the database may be somehow shared, somehow managed, partitioned or not. It may look differently, right? But if you have a dependency on another component that can't scale, you can scale too, that's obvious. But people forget to investigate their dependencies, to realize what actual graph and what actual limitations are there when we run our service and we try to put to squeeze more of it. And in the end, if it's not good enough, something is wrong. Applications, they still break. Now we see it as a failed pods, restarts, right, slowdowns, unexpected autoscaling, different things, but it can be broken. So let's get back to our favorite things, right? Cats and dogs. I wanted to make another creepy picture of cat and dog, but maybe for another talk. It's so interesting that we now have that cool new Spring Boot, because I previously made a kind of an earlier version of this talk, and I used a preview version of Spring Native. So it was Spring Boot of some version, like a developer thing. And now results are very different from what I've shown before, which satisfies me. It took some time to get them, but yeah, it's funny. So we can create either a fat jar or, you know, exploded set of files, which will take about 60 megabytes. Or we can, and it requires JDK, of course, to run JRE or whatever. So we need Java runtime, which will take, if we don't cut some modules, about 100 megabytes. It will add to the container size. Or we can create a native image, right, which will take like almost 190 megabytes, but it won't require any JDK. Comparable, right? But when we want to create containers, finally, containing that artifacts for our deployment, what should we do? Right? We have our standalone applications. We can easily take them and run somewhere, but we want to run them in containers. A funny observation is that IDEs nowadays make us have and write Docker files. Who experienced that? No, I think everyone. You have your Docker file. Who doesn't have one? 2. Okay, you're lucky. So you don't write the Docker file yourself. Does someone write them for you? Okay, interesting. So not too much changed since that questionnaire. I think it's like maybe 1.5 years old, but maybe 2. So mostly those are manual Docker files. There's no proper way of doing things. We just talk about more convenient ways or easy ways to avoid some pitfalls. Well, but often we hope for some wonders. We hope for magic. So that some service provider will extract the tool and it will containerize our applications. And they try to pretend they have that magic. Different service providers, they have such tools. But what it does, it actually helps you to forget about all the boilerplate with JSON and YAML files, different keys and whatever. But it doesn't provide you that. Your Java options, right? You have to figure out what Java options do you need in your containers, in the limitations that you're experimented with and you want to put to your containers. Well, that's probably the only choice. Okay, is it hard to do it yourself? Well, not so hard. Just take some base image. Here it is with Alpaca and JDK21, and make some settings. You can skip some of them sometimes, but it's better to keep them. Put your code into that container, right? State that you're adding some jar files or class files. Make connections. Provide your JDK options. Maybe either configurable or not, but you have to provide some. Otherwise, they will be defaults, but you won't be happy. And explain how your application will be started. That's it. All right. But I like build packs. That's a cool technology. If there are no objections, I would vote for that. But for now, IDEs don't vote for it. But maybe that will change. And build packs is a concept when you use a tool that knows how to make things with your sources. And see, oh, okay, please build my Java application packs. And it will be built. And then you don't have to provide too much information, right? It's kind of slightly similar to what generic build systems do, but not entirely. Because it focuses on having your tooling, right? And having your build environment to make it reproducible, to make it standard, to make it configurable. And build packs exist not only for simple tasks like compiling your Java code, but also for more complicated tasks like assembling your container from your Spring Boot application. And that's my favorite part here. So if you use quite recent parent Spring Boot starter parent, there's already a configuration for you. So you can either create a container with a classical JVM, or you can create a container with a native image. It's just a matter of setting your profile. So here, sorry, it's a bit small, but here we execute. We say, hey, Java Home is a Java 17. We will use Maven wrapper. We will execute profile native, and where we build a Spring Boot container image, Spring Boot build image. That's the goal. That's it. We have nothing on our machine except a JVM capable to run Maven. doesn't have to be a JDK either. So it can be just a JRE. And a container management system. Here it's Docker. And it will create an environment for us represented as containers. And in that containers, it will build other containers that we will be able to deploy somewhere. Or for example, on the same machine. So inside that, we can see that yes, we create a native image, and Liberica native image kit will be used. I mentioned it is the default compiler here, and it's here. It's version 23 based on JDK 17, which doesn't really matter for native image compilation. But there are some settings, and that settings influence knowledge available inside our container built by this build pack about how much memory do we need to reserve to let JVM to use the rest of the memory and don't crash. So we will see a tiny part of the starting service slightly later, but that build packs can be viewed as a builder part, right? All that environment that lets you run compilers, complex computations, configuration, whatever. And of course the runtime part, the much more lightweight, the part that is able to correctly start your application, maybe make some understanding of your provided settings, whatever. And they may be based on different things, right? Here it's all Linux on the same with the same CPU architecture, but those are quite different. So when we start such a container, you see we already got that JVM settings, which is a real magic to me. So we have that knowledge of how much memory to reserve for native buffers or for thread stacks, because we know how many threads there will be for Tomcat, and we know kind of default stack size, so we can figure it out. And it's a kind of a starter script put there for you that does this heavy lifting. And after that, it replaces itself with the JVM process that actually runs your application. But it has that flex. So you effectively utilize that available CPUs and memory inside your container. And it also provides some diagnostics flags, which by default give you useful information about your application while it works and when it exits. Super convenient. It's a mix of technologies, but in the runtime, it is simple. I mentioned some tweaks here. Of course, we can change Java options as well, placing some manual settings, right? Like in the example with manual Docker file, I said, okay, use like 75 or 80% of available container memory in any case. At that point, you already guess or assume how much memory will you have in the running container, right? So your application won't crash if you say, let's use 75% of memory. And that means, okay, monitoring alarms, then it's 80, and probably we'll have container with 4 or 8 gigabytes of memory available, so that should be fine, and the application won't crash. But if you'll get a pod with like 1 gigabyte of memory, might not work, right? It's an elastic setting, but you still should understand what are the boundaries of your values. So if we look at some images that are created, that are used during our container publishing process. So first, there's a base image that I used in the Docker file example. It's rather slim, and it's even better compressed, of course. There's a huge image used to build your native executable, right? That contains some of the tooling for native image compilation, but it's already there, right? You've got it. It works. You can purge it when you don't need it, so it's easily manageable through Docker tools. And there are resulting containers, right? So you can create a tiny container based on Alpaca, which will take only like 150 or 60 megabytes, right? Or you can have that native image one, which is created by build packs, and it's only like 220 megabytes, or classical JVM build pack created image, which is 337 megabytes. Not bad though, because who haven't seen from OpenJDK in Docker files? Right, don't raise your hands. We all saw it. And in that case, you get that enormously large bloated container. Well, all right. We can optimize applications for containers, or we can optimize containers for our applications, right? Because we have that complex problem of how we should size our pods and nodes, the entire deployment, to satisfy the quality of service, our SLOs, the amount of work we are able to perform. So in my case, I'll say, all right, let's respond not slower than 100 milliseconds for the entire cluster. Let's maximize our throughput, requests per second. And let's be nice to developers. I will show or mention it later. So I will use just a simple load testing tool. It could be K6 or JMeter as well, or I don't know, other more Kubernetes friendly tools. That's just an external harness. I will examine only one endpoint in this application, a very simple one, of course, with different levels of the load. And the first question is what to use as your baseline, what to choose from, what are possible pod sizes. And here I say, okay, let's plan it simple. We probably want to scale using autoscaler, which limits us in pod type selection. We're always limited in pod type selection. But if it's not autoscaler, probably we have greater selection. There are interesting practices, like in many organizations, there are funny rules, and people say, you only don't need any additional approval if you use the cheapest instances. If you use more expensive ones, you need an approval. So what people do? They don't test their performance and they use the cheaper instances. And they waste a lot for the organization. But no one cares. So, let's start with a very simple primer. We only have 8 CPUs for Java, but on a server class machine, and we limit its max memory to see what's the current performance of our application which is not containerized. What should we struggle or compete with, right? And it can be different. That's a separate topic, not covered here, but I specifically used defaults, right? Build packs. So it's JDK 17, which gives very good, but not the best results. And with this application, which can be already compiled to native image, not as a container, but as a binary, we can get some RPS, like 3000, right? Or we can get RPS for the application running on a classical JVM. And that's the level of throughput of this application being warmed up and having its latency below 100 milliseconds, which is kind of, and all the numbers are quite approximate, I would say. Don't believe me, but take it as a reference. this is how we can make the experiment, right? We can scale this application vertically, in fact. Sometimes it's hard, but here, yes, we can add memory, we can add CPUs. What else we can add? Hey, this is a Spring Boot application. Your code, responding to some requests, running on web server, Tomcat. Threads, yes, exactly. So we can change the number of threads, probably making it slightly more. But it's interesting, when we expand memory, when we put greater XM access, we probably need other tunings. Because at some point, our compressed oops situation becomes non-compressed oops, and even G1 without any additional settings becomes not so great in terms of latency. So we either need to tune it, or we have to put a different garbage collector, but it's possible. So we can scale this application vertically, but it requires non-trivial effort, right? Not just experiments without changing JVM flags. And I'm going to the latter. So yes, I mentioned the latency, probably it's like this. This is a completely not honest picture made here just for reference. So in fact, there are maximum numbers of requests per second that happen when application warms up, right? And absolute numbers are very different, but just to remind you that there is a warm-up, right? We have latency becoming better if we don't overestimate our throughput expectations. And we have maximum throughput becoming better over the time. So next move, let's put that application into a single container, right, and run it. Surprise! In my previous experiments, much earlier, there was a difference. Now it's the same. So we have same performance inside the container, which is important because containerization may influence us directly. Now let's put in a single node cluster as a single pod, right? Well, it's the same performance. Good. Again, it may be not true because I've seen it. So, proved. Let's throw in some resources, right? Let's try to replicate this application. It will still fit this machine and the possible node that we can get with some ports on it. So we have more instances. How do you think? Will it be better? So the real horizontal scaling, right? We finally put it into a cluster and scaled horizontally. We have an ingress that balances all the requests. Yeah, it is really better. So we have 20K requests per second, which is our goal, right? At the same machine where it's hard to scale this application vertically, we scale it horizontally, even without, additional things in cluster. And it brought some benefits to us. Now we start to put less CPUs there, at smaller instances. Why not? Because they told us to use cheaper instances. No. Now we started to wait for the application to start. We have an unstable latencies and throughput, and we have to wait for a very long time to wait for the application warm up. With the same hardware resources, we pay for the same. But we just misconfigured our cluster by this funny recommendation. So we have that initial warm-up with all the JITs working, right? And they are starving of CPU resources. So it takes so long. And then the application is warmed up, but it's still slow. Well, some people do this, right? But that's not friendly to developers. I, developer, reject this because it takes just, 10, 20 minutes to start the cluster. The same hardware, same machine. But we wait for every single super small pod to start. Okay, let's get back to native. Does native scale? Yes, it scales as well. But again, don't put that half of a CPU pods. No, for services under load that doesn't work. Well, it works very badly. Just don't do that. That's for services that are unused. Okay. So finally get it running and scaling. That's happiness. But don't remember, you have to control the entire process. Starting from thinking of what your architecture is, what your approach for deployment, what's the life cycle of your application. So you have to plan in advance. What's your scaling strategy? What are your possible resources? And to start testing, find out what resources your application, what does your application require, right? What you can give to it. What are the options, right? What happens inside? Are there any problems happening when you have that or other settings? How your business perspective changes. So you have to track all the data, all the indicators early, right? Then you go to container images. Be wise. Set your settings. Prepare your application to run in the cloud. No one will do it after you have shipped it, right? It will be just executed with some settings and control that settings, saying, hey, we don't have that settings from production on our staging. Why? And DevOps people say, well, it's too expensive. No, it's too expensive to solve real problems, failures, right? So developer clusters are super important, and companies try to save on them, right? It's understandable, but maybe it's not a good idea. Put some tuning. Use extra options. Use crack, AppCDS, whatever problem you solve. You can find a solution. You can have an instant startup, but again, you have to provide some CPU resource and memory, even for native images. No one can work with 0 resources. And JVM is multi-threaded whenever you give it one CPU or not. There are multiple threads doing their service work, which is important. So we propagate our application parameters. And we can use helpers, right? Especially if we write Docker files, but don't rely on them too much. Perform testing. As well as you perform functional testing, please perform performance testing in the same manner, like A/B testing, different kinds of deployments, canaries. Kubernetes provides that for us. Just run it and try with your performance testing tools or monitoring. And then use that monitoring in production. So you have to get feedback of how your services are working, what are real problems, what's the point of scaling for them, right? Because many people scale on CPU, and you see CPU consumption may be high not because of the high incoming requests, but because of misconfiguration, a lack of early performance testing for those services. Yes, we can optimize all that. Just involve developers in that container cost and resource utilization optimizations. Yeah, thank you. We have more information on our blog, and I'll be happy to see some questions. Or you can just raise your hand and ask a question. Yes?
How would you handle such optimization on large scale when you have not one application, not two, but hundreds of them?
Hundreds of applications. How would we handle hundreds of applications? Somehow, that hundreds of applications don't break. So there's always someone who is responsible for an app. Because if there's no one, that's a too high risk. Even if sources are never built, etc., someone has to keep an eye on that. And you don't have to rebuild your application, right? You can rebuild your container, you can change options So it's possible even if you don't really have deep understanding of what happens. You can analyze your native memory, etc. Same techniques. Yes, it is work. It doesn't happen automatically.
It takes eternity.
Yes. Sometimes it takes eternity, but the alternative is worse. Yeah. No. Let's see. Last chance for Slido. No Slido questions. Thank you. No Slido questions. I like raised hands. All right, you can catch me here afterwards. Thank you for your attention.